Now, part of this topic is to do with acids and bases. In fact, a significant part of it is to do with that. And last year, you'll have learned about strong acids, strong bases, weak bases. And it's really imperative that you have a really good understanding of the difference between those. A typical strong acid is hydrochloric acid. And when you put that into a solution of water, and whenever you do these equations in Year 13 chemistry, this is aqueous chemistry, so make sure you include water. When this reacts, it completely dissociates. It doesn't matter which way I put those around, and I should be putting AQ and AQ around these things. So if we start with, for instance, 1 mole of that, it's going to form 1 mole of that and 1 mole of that, and there'll be no more of this left. It completely dissociates. Now, a weak acid, when you put it into water, it partially dissociates. Okay. Now remember, when you're doing acid equations, you're always going to have H3O+. When you're doing base equations, you're always going to have the hydroxide ions. Now, with weak acids, it only partially dissociates. So if you had, for instance, 1,000 CH3COH particles, now this is not an exact number, but instead of having 1,000, you might end up with 999 and just one conjugate base and just one H3O+. So the equilibrium is well to the left. Okay, so you've got mostly reactants present. So that means hardly any conjugate base and hardly any hydronium ions form. And last year you'd have been asked questions like, for instance, if you have 0.1 mole of each, why do they have different pHs? Well, that's because the strong acid completely dissociates, and it would produce 0.1 mole per litre H3O+ here, and the weak acid would only partially dissociate, would produce very low concentration of this, and as pH is a measure of how much hydronium ions, we wouldn't expect a weak acid to have the same pH as a strong acid for the same concentration. Now in the case of a strong base such as sodium hydroxide, that forms sodium ions and hydroxide ions. Note, this reaction often the equation students don't write well. Sodium hydroxide is usually a solid. When you put it in water, it's really just the equation you're writing is an ionizing, where it splits up into sodium ions and hydroxide ions. Okay? And that goes to completion. Ammonia is a weak base and will form ammonium and hydroxide ions. Now, again, this is a weak base, so it only partially dissociates. So once again, if you have 1,000 of these, probably 999 will be ammonia, and just one will be ammonium, and just one will be hydroxide. So this is the main difference between strong acids, strong bases, weak acids, and weak bases. Complete dissociation with strong versus partial with weak.